Welcome! In today's lesson, we're going to evaluate the integral of cosine to the fifth power of x divided by the square root of sine x with respect to x. We will use substitution to simplify this integral. Let's first write down the integral. To evaluate this integral, our first step is to set up an appropriate substitution. We notice we have sine and cosine terms. The trick is to set u equal to sine of x because its derivative, cosine x, also appears in the integral. Take the derivative of u with respect to x. This becomes du equal to cosine x dx. Next, let's express the integrand in terms of u and simplify. Since du equals cosine x dx, the original expression of cosine to the fifth power of x divided by square root of sine x dx can be rewritten as cosine to the fourth power of x times cosine x over square root of sine x dx. This means that we have cosine to the fourth power of x equals cosine squared of x squared, where cosine squared of x can be substituted with 1 minus sine squared of x. Taking this into account, our integral becomes the integral of 1 minus u squared all raised to the power of 2 times du over square root of u. Now let's expand the expression within the integral. Expanding 1 minus u squared raised to the power of 2, we get 1 minus 2 times u squared plus u raised to the power of 4. We can now divide each term by square root of u and write it out separately. Our next step is to integrate each term separately. We're going to put each term into integral form, solve for the integral, and write down the solution on the right. Once each term is integrated, let's combine them together. The combined solution will be 2 times u raised to the power of 1/2 minus 4 over 5 times u raised to the power of 5 halves plus 2 over 9 times u raised to the power of 9 over 2 plus the constant c of integration. We now return our solution back to the original variable using back substitution by replacing u with sine of x as we originally defined. And there you have it. We have successfully evaluated the given integral using substitution. The approach begins by setting a strategic substitution, then utilizing variable transformation and expansion to simplify, further integrating the resulting function, and finally returning the solution to its original variable. Thank you for watching.